Throughout my career as a design engineer in the automotive industry, working on some of the most advanced and elite cars, I cannot claim to have been a master, but I have had the privilege of meeting many talented engineers. Many are good engineers, some are great engineers, but only a handful stand out as true masters. Their impact on design and products is immense. These individuals are like beacons, guiding other engineers and pushing the boundaries of innovation. I've had the chance to work closely with some of these masters, and I've always been fascinated by what sets them apart. Today, I want to share with you the secret to becoming a great design engineer. And trust me, the third point I'll share is a life changer. So stick around till the end. Here are my insights. Number one, they put themselves and all their senses into the design. Great design engineers use more than just their brains. They use their entire being. They immerse themselves in the design process, feeling forces, understanding dynamics, and visualizing the behavior of every component. Let me tell you a story. One time I was in a deep discussion with a master engineer about the force path inside a mechanical drive unit. I was using analytical methods and complex equations to figure out the force path and reactions, as any typical engineer would. But this approach was different to his. Almost instinctive was his approach. He looked at me and said, "Imagine yourself sitting on a chair on this surface, holding a weight on top of your head. The chair is supported in these points and the weight is guided in that direction. If the weight is increased a lot, in which direction would you move?" I took a moment to visualize it, and suddenly the force path became clear. That's the power of putting yourself inside the design by imagining yourself as part of the system, replacing each component with your own body and senses. You gain a profound and intuitive understanding. On another occasion, a master designer demonstrated a similar tactic. He was asked if a torque of 8 Nm could be achieved by a specific drive system. Instead of running straight to calculations, he extended his arm, thought for a moment, and said, "No, that's not feasible." When I asked how he knew, he explained, "My arm is about 80 centimeters long. Imagine I'm holding a 10-kilogram weight at the end. That's roughly 8 Nm of torque. I can feel it's too much for this system." His experience and ability to physically relate to the forces gave him immediate clarity. This is not to say that this intuitive approach replaces calculations, but paired with calculations, you are a lot faster and less prone to mistakes. To be able to use this tactic, you need to train yourself to do so. Go over engineering statics and dynamics again, but this time from the very basics. Replace the objects that you are calculating by your own body. Step by step, gradually increase the complexity. It will become an intuitive approach to you. Number 2. Master GDNT to allocate precision where it matters most. Another key trait of great design engineers is their mastery of geometric dimensioning and tolerancing, GDNT. This skill allows them to make functional features highly precise while leaving non-functional features less refined. The difference between a regular design and a master design lies in how precision is distributed. A regular design often applies a similar degree of precision across all features and dimensions, but a master design pinpoints functional dimensions for high precision while keeping irrelevant features rough. This strategic approach ensures that the available budget and resources are allocated to what truly makes the difference in the performance and reliability of the product. Let me explain how GDNT gives you this power. It provides a clear framework to define the allowable variation in the geometry of the parts. By focusing on functional relationships, such as how two mating parts interact or how a specific feature affects assembly, you can achieve precision where it's needed most. This approach not only saves time and cost, but also enhances the overall quality of the design. For example, consider a critical mounting hole for a mechanical component. A master engineer will apply tight tolerances to this feature to ensure precise alignment and reliable performance. In contrast, less critical features such as cosmetic surfaces or non-functional edges can have looser tolerances, reducing manufacturing costs without compromising functionality. Number 3. Use a matrix approach to generate concepts, a life changer for every design engineer. Good ideas may come by chance, but great engineers don't wait for luck. They create great ideas. They create them through a structured approach. One of the most effective methods is the matrix approach, which breaks design requirements into sub-functions. For each sub-function, you list all the possible solutions, whether feasible or not. This brainstorming phase allows you to put every idea on paper without judgment. Once you have a comprehensive list of potential solutions for each sub-function, the next step is to start combining them into compatible solutions to generate several product concepts. To evaluate these concepts, master engineers use a parameter-based point system. By assigning scores to factors like cost, manufacturability, reliability, and performance, they can objectively judge and refine their designs. This approach not only ensures a thorough exploration of potential solutions, but also creates a clear pathway to the optimal design. By systematically assessing problems and exploring solutions, great engineers consistently produce innovative and efficient designs. I'm currently working on a detailed course to teach this matrix approach step by step. I will update you once it's ready. So stay tuned.